Chapter 5, Section 4, Master. We're going to continue with difference of squares, but for these examples, we are going to have to factor out a GCF first. And remember, any type of factoring that you're faced with, the first thing you always look for is a GCF. Sometimes there isn't one, but in this case there will be. So factor 2x squared minus 18. The GCF is 2, so I can factor that out. That leaves x squared minus 9. And you should recognize that this here is a difference of squares, and that can be quickly factored as x plus 3 times x minus 3. And don't forget, this 2 still has to be there. Next example, the GCF is x, so factoring that out leaves an x squared minus 100. And this, of course, is a difference of two squares, because that is 10 squared. So your final answer, you get x times x plus 10 times x minus 10. So just like before, we're just pulling out a GCF first. Here we can see that the GCF is 5x, so I can pull that out, which leaves 4x squared minus 1. All right. Yes, this is a difference of squares, so I get 5x still. And factoring this quickly, I get 2x plus 1, 2x minus 1. And that is done. X to the fourth minus 16. Now there's no GCF to take out, but x to the fourth, that is a perfect square. That is x squared squared. And this can be written as 4 squared. So I can factor that quickly. That would give me x squared plus 4, x squared minus 4. Okay? Now you might be tempted to stop here, but look, this is still a difference of squares. So we always want to keep going as much as possible. This happens to be a sum of squares. Those are not factorable. So there's nothing I can do. So that remains x squared plus 4. But this can be broken down further to x plus 2, x minus 2. So there's a little bit more factoring involved, but still difference of squares. Next, look for a GCF. That is a 6y, leaving x to the fourth minus 1. Okay? This is a difference of squares. Remember, this is x squared squared. So I get 6y, and I get x squared plus 1, x squared minus 1. And I'm not quite done because this here is still a difference of squares. So I can actually do quite a bit of factoring in the end. Okay. Again, this is a sum of squares, nothing I can do, but I can break that down to x plus 1, x minus 1. Over here, if you notice that we can just change the order as long as we don't change the signs, now it's perhaps a bit more clear that we're dealing with a difference of squares. So I can quickly factor that. I get y plus x, y minus x. So that's an acceptable answer. Next, I can see that the GCF is xy. So that leaves 25 minus y to the sixth. All right. This is a difference of squares, because remember, y to the sixth, okay, I'll just write that up here. Y to the sixth can be written as y cubed squared. So that's where your square is hidden. So I can break that down. I still have xy. This becomes 5 plus y cubed, and this would be 5 minus y cubed. Okay, a perfectly acceptable answer. If I want to change the order, just be careful. These are both positive, so I can write y cubed plus 5. But if I want to write y cubed minus 5, I've changed the sign, and I can do that if and only if I factor out a minus. So I'll put that right there. It's a divisible negative 1 that I factored out of here, so I can write it in this way. Right. So in practice, both of these are perfectly acceptable. Factor t to the power of 8 minus 1. There's no GCF, but I can tell already there's going to be quite a bit of factoring here. Remember, t to the 8 can be written as t to the fourth squared. So I can write this as t to the fourth plus 1, t to the fourth minus 1. Okay? But this here, that's still a difference of squares, so I can break that down even more. So the t to the fourth plus 1 remains unchanged, and this becomes t squared plus 1, and then I get t squared minus 1. I just keep cutting the exponent in half. But this, that's still a difference of squares, so I can go one more time. So I get t to the fourth plus 1, t squared plus 1, t plus 1, t minus 1. So quite a bit of factoring, but not too bad. With the last example, even if I change the order, okay, both of them are still negative. Even if I factor out the negative, then I get y squared plus x squared. Okay? This is a sum of squares, not a difference. This is not factorable. So that's my answer. Not factorable. It is not a difference of squares. That was easy. Done. All right, so for these examples, we're just going to fill in the blanks. Now, we are under the assumption that we're dealing with the difference of squares. So that's a squared minus b squared equals a plus b times a minus b. All right, so x squared minus 49, that would be x plus 7, x minus 7. That's simple. So I have 25x squared minus blank. Well, this would have to be 5x plus something. This is 5x minus 6. Okay, well, that has to be plus 6, which means this had to have been a minus 36. So again, I'm assuming that this is a factorable difference of squares. So it makes it a lot easier to try and determine what these missing numbers have to be. All right, so t plus blank, blank minus 1. Well, that has to be a 1. That has to be a t. So that must have been t squared minus 1. Pretty simple. The last one, little bit tricky. You've really got to be careful with this one because we actually have something that we could factor out. Look over here. This is not a difference of squares yet because there's a 5 here. Okay, 5 is not a perfect square. So the only way this can be factored as such is if I was able to factor out this 5. Okay, so the 5 must have been pulled out. Otherwise, there's no way I could factor it as a difference of squares. Okay, so this is x plus blank. Blank minus 3y, so that must have been x minus 3y. This is x plus 3y. Okay, so the left side is done. So what does this have to be? Well, this comes from the last term, so you might think it would be a minus 9y squared. But remember, we had to have been able to factor out this 5, and the 5 would have come out of both terms. So in fact, this should be, hang on, why does it not want to erase? There we go. That should be a 45. And if you can't see that, just FOIL all this stuff out and then multiply everything by 5, and you'll see where the 45 comes from. Okay? Or you can just factor this. Okay, we're just checking now. So factor out a 5. That leaves an x squared minus 9y squared. Okay? The 5 stays there, and of course I can factor that as x plus 3y, x minus 3y. Okay? Which matches what I have here on the left.